Good afternoon, everyone. Our project title is Detection and Classification of Non-Proliferative Diabetic Retinopathy using VGG-CNN algorithm. So usually diabetic patients have the tendency to fall under the eye disease which is called as a diabetic retinopathy. Usually this diabetic retinopathy is divided into the two types, that is non-proliferative diabetic retinopathy and proliferative diabetic retinopathy. Proliferative diabetic retinopathy is the earliest severe stage and last stage of the diabetic retinopathy, whereas non-proliferative diabetic retinopathy is the very early stage of the diabetic retinopathy, which have the 5 stages, that is no NPDR, mild NPDR, moderate NPDR, severe NPDR, and PDR, that is proliferative diabetic retinopathy. These are the symptoms of the diabetic retinopathy. NPDR detection and classification tasks have been addressing using variety of the machine learning methods, including the support vector machines, KNN, and deep learning CNN algorithm. These machine learning algorithms often need to extract the useful features from the retinal pictures, which may be the difficult and time-consuming operation. Their method was accurate, but it did not account for the variability in the retinal pictures and did not apply the transfer learning, which may restrict the models of regenerability. NPDR detection classifications have the difference. These machine algorithms often need to extract the useful features from the retinal pictures, which may be difficult. In this process, VGG19 CNN model to detect the classify non-proliferative diabetic retinopathy. This model is classified into the 5 stages based on the number of microenormous hemorrhages, soft acutes, and hard acutes are there. In this project, we also includes the ability of the transfer learning approaches in increase the performance of a processed thing. So, to understand the concept of diabetic retinopathy in image from existing literature and build up problem statement from the processed CNN based algorithm to add the augmentation technique and transfer learning techniques to enrich images. Develop a VGG19 CNN model that can accurately detect and classify NPDR from the retinal images. Evaluate the training modeled performance using measured accuracy, sensitivity, F1 score, and specificity. Compare the performance of VGG19 model of NPDR detection and classification to the CNN model and machine learning such as KNN and CNN. Develop a user interface that applies the establishment of model, new retinal images, and evaluate the images performance in a real world settings. We have to compare the VGG19 model for NPDR detection and the classification of CNN. So we can see the flowchart where the image is sent to the augmentation and then it is sent to the pre-processing and then VGG19. Then it is divided into the 5 stages. So we can detect the first stages. Images are used datasets that are aptodes and edges. Aptode datasets are 3662 images, which is classified into the 5 stages, in which each class is containing 733 images, whereas edges have the 399 images, which is divided into the 5 sets. To split the datasets for training and testing, we have randomly selected the 20% of images from the both datasets for testing process. Augmentation is a technique used in deep learning to artificially increase the size of training datasets by applying the transformations such as rotation, flipping, zooming, shifting, and to the original size. By doing so that the image is trained on a variety of different images, which helps to make more robust and accurate when it comes to the predicting of unseen data. We have used the image datasets from Keras library to perform the data augmentation. So, pre-processing refers to the stages that is prepared in the image input data for feeding into the deep learning model. This typically includes the standardization, the pixel values, and resizing the images to the fixed images and converting the images to the format that model can process. We have to target the size of the pixel size is height and the width of 2 to 4 pixels. The image will have 2 to 4 pixels. Library detections, the number of images that will be fed into this. So VGG is a deep learning convolutional neural network architecture. It consists of a 19 layers, includes 16 convolutional layers and 3 fully connected layers and one softmax output layer. VGG19 can be used as a powerful tool for analyzing the fundus images of the eye and detecting the presence of the retinopathy. The architecture is designed to extract the features from the input images and classify them into the different stages. VGG19 is a diabetic retinopathy detection, involves a fine tuning and pre-trained model on this. We can see the convolutional layers of the CNN algorithm. So KNN is a simplest classification algorithm that is based on the distance between the points. It classifies a new data points based on the k nearest to the points training. KNN is a slow working when it comes to the large data sets, and it is very sensitive to the choice of the distance metric. You can see the diagram. SVN is a learning algorithm that can be used for the both classification and regression process. SVM can be used to classify retinal images into the different stages. The results, you can see the accuracy there. We got a 96% accuracy. So the main motto of this project is to aim the early stage, the very early stage of the eye disease, so that it can be treated in the very early stage, which will be helpful for the very people. Thank you.